Good afternoon to all. Deepthi, yeah, you can start introducing the resource person.
And she's a
Deepthi, your voice is not audible.
hello.
Yeah, Deepthi, now it's okay.
Okay, ma'am. Welcome to a short-term training program on research trends in renewable photovoltaic system and its research challenges. I consider it a great honor to speak about our chief guest, N. Kumarappan Garu. He has received the graduate degree from Madurai Kamaraj University and postgraduate degree from Annamalai University and PhD degree from CEG Anna University. He is currently working as a professor with the Department of Electrical Engineering. He has published more than 129 international journal and conference papers. Dr. Kumarappan is a life fellow of Institution of Engineers and life member of India Society of Technical Education. He is an IEEE Madras section chairman, IEEE CIS Madras chapter chair, and a coordinator for more than 100 IEEE Madras section organized FTPs. Of IEEE Madras Section Motivation Award in 2010. He was the organizer of a special session in IEEE WCCCI 2010 Spain. He was the outstanding reviewer for the Elsevier International Journal of Electrical Power and Energy System. I welcome Dr. N. Kumarappan Garu. Welcome, sir.
Good afternoon. Good afternoon to one and all. First, I'll share my slide. My slide is visible.
Sir, now meeting link is visible, sir. PDF. So press on the PDF file, then it will be visible, sir. Please click on the PDF file.
Already it's open. The PDF file is already open.
Yes, sir. It's, it's presenting mode. Okay. Sir, it's presenting mode only. We can see your screen, sir. The meeting link is visible. If you press on the PDF file, then we can see the PDF file, sir. If you click on that one, full screen.
I'll open in my screen.
Yeah, full screen is shared, sir. So meeting link is visible for us. Yeah, now it's okay, sir. It's visible.
No, it's okay.
Yeah, yes,
Right.
sir. It's visible.
Good afternoon to one and all. I think so. Now you are in the 10th session of listening, otherwise hearing the session. Therefore, till now 9 sessions are completed. You learned a lot. Otherwise, you based on the theme of the topic they have shown, you know, basic knowledge as well as the new ideas. I think so. You got all that through the continuous sessions. I got the chance of attending the morning session. The morning session is also a very interesting one. He explained about the control, a different kind of a controls, that too with the latest controls, and is concentrating on again on the microgrid. Very important thing is he introduced a concept of frequency-based dispatch. It is entirely a new kind of a direction. And even with the frequency-based kind of a dispatch, and he has selected a different kind of a control concepts that till now, what is the latest concept they use it, till now you try to use it. Therefore, that may be very helpful to you to know the latest controllers. Based on my presentation, you get an idea of what I mean by the hybrid AC DC grid. That is first about the architecture, then the operation, finally the control. The control is, I'm not going anything deeply on the control side. To make an overall understanding of hybrid AC DC microgrid. Nowadays it's essential, that too an important one. Therefore, because expecting the power from the government, it is stopped. You can't expect the power from the government here afterwards. You have to meter the power by yourself. Once, if it is decided, this kind of a microgrid plays a very important role. Once you select the microgrid, that microgrid can be connected to the main grid. Otherwise, it is to be worked on an isolated mode. There is a two kind of ways it works. And even the microgrid is one of the way of working the grid as smarter. That is a smart grid. For that to work the grid as smarter, that is, it becomes a smart grid. For that, essential requirement is one of the essential requirement is microgrid. Therefore, there is first I'll introduce a different kind of a grid to that. Before moving on to the grid, based on the power engineering, there is a two different kind of a big developing field. One is power system restructuring, other one is smart grid. These two are two important developing field. It is most successful in most of the countries, but in the restructure wise, in our country, according to the 2003 Electricity Act, it is must implement the power system restructuring. Otherwise, must implement the power system deregulation. Once you implement power system restructuring, otherwise power system deregulation, it is essential to know something about that. What is that? Till now we use only a power. Only the power flow is there on the line. Now the second flow is added. That's called money. Once money is added, it becomes, you can even bid the power in the market. That is power system restructuring, because the second flow is added money. From that, we understand at that stage itself, it becomes interdisciplinary. It involves the management as well as the power engineering. But that two together, once you form, you can easily form the restructuring, otherwise deregulations. What they expect from this restructuring, according to the 2003 Electricity Act of India, the customer, they always expect a minimum power with a minimum cost. But the supplier always expect a maximum profit. Is it possible to attain it? Really a great task in front of us as a researcher, otherwise as well as an once you join any kind of an industrial. Otherwise, you're an industrialist. But there is a big challenge in front of you. Is it possible to attain the maximum profit for the supplier and minimum cost for the customer? That is an objective of power system research. Already it is successful in abroad, but now in India, it's only in the testing stage. Almost all the electricity boards are implemented. Therefore, most of them, they've done Transco, Genco, Disco. They unbundle as 3 kind of things. But in Tamil Nadu, they have unbundled as only 2. That is Tangetco and Disco. That's all. In Andhra, I think most of the places they unbundle as 3: Transco, Disco, and Genco. But very important thing is, already in Andhra, the loss wise compared to all other states, they are really, the consumption of loss in the transmission line is very, very less compared to the other state. That way we have to appreciate the Andhra electricity board, otherwise new kind of a way they form as Genco, Disco, Transco. That is also to be appreciated. Therefore, that is a very important concept in the transmission wise. For even in the fundamental wise, whenever I'll make a presentation, I always concentrate on the fundamental. Once you are thorough with the fundamental, you learn the remaining things very easily. My aim of presentation is make you to understand. Once I even give some of the basic concept, remaining things you can learn yourself very easily. Most of them struggling to understand the fundamental. Even it may be a teacher. Therefore, they are thorough with the fundamental. Once they start the class, with a very good confidence, they can manage easily. But in that way, even initially, there is a big fight between the scientists, which kind of a grid to be selected. Therefore, among them, what they decided means the grid is AC grid. The reason is they produce the power in AC. The transmission also in AC, it reaches to the power to meet out the load. So finally, they decided AC grid. But what happens now? Now, the present day grid is not so. It is changed as a AC-DC grid. Because in the beginning of the days, they can't select the DC grid because it's very costly. The converter, inverter, everything is very costly. But nowadays, it is not so. The cost is reduced. That's why they concentrate on DC. Therefore, the DC transmission also becomes very popular. Now, what is the present day grid? That is the AC-DC grid. That is a clear-cut way we can say the present day grid is AC-DC grid. In future, it will even become a DC grid. That's possibility also there. Therefore, once we move on to the AC grid, why we concentrate on the high voltages and everything on the line to reduce the losses. Even directly move on to the DC kind of a transmission, it is reduced further. The loss is reduced further. But that is the way. Once finally it comes to the level of DC grid, the losses can be reduced a lot. But beyond that, the direction of the grid is entirely differs because of the latest developments. Therefore, now I introduce a microgrid. What is the way I introduce a microgrid? Why it is called micro? If it is electronically, we say micro, it is microprocessor. Then only we realize it's 10 to the power minus 6
Sorry, sir.
milliampere.
Sorry to disturb you, sir. So first slide only visible for us, that in your name and the college name only. The slides are not moving. It's
No, don't worry. I'm not moved the slides. Right?
okay, sir. Some of the
only I'm giving the introduction. The one once I start, I move on to the slides. Okay.
Okay, sir. Thank you, sir.
Okay, please be concentrate on and always join with me. Okay, I think so. Once you join with me, then you understand what are all now I introduce you. What are all I introduce you, I'll definitely use it inside my slide. Right? Okay. Therefore, then only you can understand the remaining things very easily. Right? Okay. Therefore, don't worry about the slides. I'll move on the slides. Therefore, the microgrid. Once now I'm talking about the different kind of first microgrid. Why when we realize the word micro, but the micro one is if it is electronics microprocessor. When we realize milliampere 10 to the power minus 3, because of that only. Why compared to electronics become very popular? The reason is electronics is minimum power consumption as well as the size is very, very small. That's why it becomes very popular. Now the electronics dominates, But you may think that electrical may not. It is not so. Equivalently, electrical also developing, but it may not be popular like electronics. The reason is small in size, therefore consumption of power is less. That's why it's very attractive. But in the microgrid, why even beyond that, we use the micro in electrical side. Why it is so? Even we can produce a kilowatt of power. That's why it's called as a micro. Till now, you know them. Once they install a unit, the unit is only in megawatts. Therefore, to produce such a kind of a megawatt, we require data, Birla, Reliance, like such a kind of a big people. But we move on to the micro, only in kilowatts. What happens? Once we move on to the kilowatts, it's not necessary to, such a big change is not necessary to produce a power. Anybody become to produce a power. That's why I told you, we can't expect the power from the government anymore. Therefore, you have to meter the power by yourself. If you are a college, already I know that through your schedule, the SVC colleges already erected the solar panels on the rooftop of their colleges. They are meeting up the power by themselves. That's the initial starting. It was the same kind of a way. All of them have to meter the power by themselves. There the micro comes. Therefore, that's why now I introduce the first grid. That's called microgrid. The second grid, what kind of a grid is it? Smart grid. What do you mean by smart grid? I'll be based on the power system restructuring. We already introduced power can be bitted. Through that, the second flow is added, money. Now, because of the introduction of smart grid, third flow is added. That is called communication. What do you mean by that? Where there is an excess power, you can take that power. Where the power may not be available. That is nothing but an energy management. That is called as a smart grid. For example, we entered inside the classroom, all the lights are on. Once you come out of the classroom, automatically all the lights are off. That is smartness. The similar kind of way, you make the grid as smart. Therefore, you are very well, you are managing the energy. Then it is smartness. The smartness comes. For that, you require another flow. That flow is called as a communication flow, otherwise ICT, communication flow. Therefore, communication-wise, where there is an excess power, through the communication, it reaches to you. Even it may be a remote place, it reaches to you. Therefore, that is naturally the bidirectional. Communication-wise, bidirectional is no problem at all. But in the smart grid-wise, the main transmission, that also you have to make it as a bidirectional. Think about it. Those who are I think so most of them attending this session, or attending this program, is most of them belongs to power system. That's what I'm imagining. Therefore, you know power engineering. Where we are looking at the power bidirectional, is it possible to answer it? Yes, therefore, where the bidirectional, it is actually happening in the power system. Already the bidirectional is existing, the power system wise. Is it possible to answer it? I think so. Any one of them answer it through the chat box, I feel happy. Where the bidirectional it comes. Where the bidirectional it comes. Is it possible to answer it, please? Any one of them answer it. Already the bidirectional is existing on the power system. Where exactly is it? Right, the answer is not shown by the chat box. Right, that is called as the interconnected system, right? The bidirectional is already existing in the interconnected system. Therefore, the interconnected system, what is the way the power flows, the transmission line is called as a tie line transmission. That name of the tie line transmission is called as a tie line transmission. There in the tie line transmission, the bidirectional is already existing. But once you move on to the smart grid, the whole thing should become a bidirectional. Therefore, then only it's possible to make the grid smarter, because you have to give the power and take the power. That's why you require a bidirectional. Therefore, from that we understand the present grid to be re-engineered. Then only you get the smart grid. The present grid to be re-engineered, then only you get the smart grid. Restructuring is different from re-engineering. From that we understand there's a two important challenge field in front of you. One is power system restructuring, other one is a smart grid. Till now I introduced a two type of grid, microgrid. Second one is a smart grid. And smart grid is nothing but making the river as nationalized one. Where there is an excess water, where the water may not be available, you can supply. That's the concept of making the river as nationalized river. The same kind of a way we can make the grid as nationalized one. Where there is a small amount of power is there. Where there is an excess power, you can take it from there. That's the concept of this kind of a smart grid, right? Okay. Therefore, once you do it in such a way, therefore the smartness comes automatic. That's the second kind of a way. And this microgrid we have already seen, and as well as smart grid. And the next one is called as a supergrid. What do you mean by supergrid? The supergrid is nothing but getting a power from excess power from other continent. Okay, the other continent, other countries, wherever there is excess power, you can take the power from there. That's called supergrid, right? Globally, wherever there is an excess power, you get the power from there. You make it in such a way that becomes a successful one. That's called supergrid. It is not an easy task. Therefore, it is to be done you have to design designing such a kind of thing is a very tough task. Because, for example, you make a visit of abroad. One other country have a 50 hertz, another country have a 60 hertz. Even the circuit plugs differ from one country to other country. Every time you are going with the converters. Even the universal converters are also available on the market, suitable to all countries. Therefore, even that way, we are not internationally common one. That is, may not be internationally a common kind of a thing. Once you make it that as a common one, then only the supergrid may be a successful one in future. But that is the last kind of a level. Therefore, now I introduce all kind of a grid to you, as well as the power system restructuring to you, and as well as the smart grid to you. And in the smart grid, the small part is microgrid. Now, the microgrid we selected here, that is directly to be connected to the main grid. Otherwise, it can be acted as in the isolated mode. Okay, the two kind of ways we can select it. Now I'm moving on to my presentations. That based on slide-wise presentation. The hybrid AC-DC microgrid architecture, operation, and control. First, I'll introduce to you the topic-wise introduction. Previously, what is the introduction I have given? The introduction for power system restructuring as well as smart grid. Now this is topic-wise introduction. Power system currently undergoes considerable change in operating requirement, mainly as a result of deregulation and due to increasing amount of distributed energy resources. I think you already heard about distributed energy resources through the number of presentations. This distributed energy resource, or the way distributed generation, is entirely a different one. What do you mean by that? The power and the load, power station as well as the load located very near to that is called as a distributed energy. So what do you mean by that? The distribution network, only the load is located. There itself, the generating station also located, that is called as a distributed generation. Therefore, from that, what do you understand? The loss is eliminated. The transmission loss may not be there. That is advantage of distributed energy resources. You can use a DG, a different kind of, even you can use a renewable energies as a DG, or conventional kind of a things as a DG. But for example, micro turbine, particularly gas turbine, you can use it as a conventional one, also a DG. Otherwise, any renewable energy sources, you can use a DG. That is all in terms of kilowatts. That's why we are talking about a renewable and other micro turbine, otherwise gas turbines, micro gas turbine, always that produce kilowatts. Therefore, even you make this kind of a thing as a megawatts, what is the way? You already know them. It is already existing. You want to produce based on the windmills, you want to produce a megawatt, what it is called? You want to produce a megawatts in using a solar panels, what it is called? It is called as a solar park. The windmill is called as a wind farm. The wind farm produces a megawatt, solar park produces a megawatt. But if it is, you consider as a very few, it is in kilowatts. You consider as a plenty of them together. Okay, that is the way you can. Therefore, in many cases, the DER, distributed energy resources, including different technology that allow generation in small scale micro sources, and some of them take advantage of renewable energy resources. We always looking at the micro scale, micro sources. That's why it's called as most DG ones you prefer. From that we understand it is only in the micro source level. Therefore it is only there in the micro source level, right? Then what are all the renewable energies here? Once you prefer a renewable energy, what is the advantage? Not only you are meeting out the power by yourself, and it also acts as a green energy. Very important messages. It acts as a green energy. Nowadays, the green energy is essential. We have to, in future, we have to sacrifice the thermal energy, because using a coal, it produces tons and tons of emission. In the emission, we concentrate only NOx and SOx, NO2 and SO2. For that, we select always a low sulfur content coal. But nowadays, third thing we give importance, that's COX, carbon-based emission. So because compared to the carbon emission, even by the pollution of vehicle, all the kind of way the carbon emission comes. But beyond all that, maximum carbon emission comes only through thermal plant. But it continues, it reaches to the global warming. And even it continues, it reaches to the level of ice age. The ice age, no one can live. There is a movie, an English movie, based on the ice age. But it's very difficult to live at that time. Therefore, we require this world to be as long existence, as well as the future generation also require this world in a wonderful, with the wonderful resources. You have to maintain these wonderful resources, that you have to sacrifice the carbon kind of an emission. You have to sacrifice the thermal plant. Therefore, in future, all the thermal plants to be replaced with the green energies like renewable or any kind of a DGCI. Very important messages. Even a fuel cell is a green energy, but it works on the principle of electrochemical kind of a concept. But it works. It is also gives a minimum emission. That's why it is also considered as a green energy. Now the continuation. Having micro sources close to the load has the advantage of reducing transmission losses as well as preventing network congestion. And once you move on to the DGs to be located in a distributed network, that's why it's named as a DGs, and transmission losses reducing. Not only that, in the prevention of, based on the restructuring wise, it prevents the network congestion, right? That is also possible. The possibility of having a power supply interruption of end customers connected to a low voltage disturbance grid is diminished, right? Okay. Therefore, the possibility of having a power supply interruption of end customers connected to a low voltage distribution grid is diminished. Therefore, nowadays we use only low, because you make that distribution network itself the power generating stations also. Then the present concept completely changes from when you require a maximum load at the time of peak. You make that peak as off peak. That's all. Your problem is solved. Make the peak as off peak, your problem is solved. You can manage energy very well, which also smartly you can manage. From the utility viewpoint, application of a DER, distributed energy resources, can potentially reduce the demand for distribution and transmission facilities. The distributed generation, on-site generation electricity from small energy sources close to the end users. Therefore, close to the end users means, what do you mean by that? Nearer to the load. You can produce a small generating, you can locate the small generating stations there. From that, you can easily manage the things. That's called DG. DG technology yields power and capacity that range from a fraction of a kilowatt to about 1,000 megawatt. That's why I told you. DG may be producing a small capacitive power. It may be in kilowatt, but it's possible to produce in megawatt. That's an important message. In contrast to the large-scale generating station locating far from load centers, DG system employ numerous but small plants, can provide power on site with little reliance on the distribution and transmission grid. Therefore, from that, what we understand, the generating stations are located near to the loading stations. Therefore, once you are done, therefore, what happens? Therefore, you cannot rely on the present kind of a distribution network, otherwise transmission network. Okay, both are very nearer. There's such a kind of a long transmission lines, otherwise other kind of a things not at all required. Therefore, low environmental impact, very important message. Use the DGs, most of them is environmental friendly and pollution free. Therefore, that is low environmental impact. It acts as a green energy. That's why naturally we have to prefer the DGs. Microgrid, cluster of micro sources, loads and energy storage system that operate as a single controllable system, right? Therefore, cluster micro sources, loads, energy storage system that operates as a single controllable system. All you make it as a single controllable system. That's all, microgrid concept. You can even connect with the main grid, otherwise may work it in the isolated mode. Operated by connected to the main grid or can be isolated from the main grid. The multiple dispersed generation sources and ability to isolate the microgrid from a large network would provide highly reliable electric power. Very other important concept, reliability. Because of this introduction of this kind of a multiple dispersed generation. Therefore, they are really struggling to name the distributed generation initially. Even they think about to name the dispersed generation. But finally, they've decided distributed generation is a suitable name. Therefore, here that's why they use the word multi-dispersed generation source. And ability to isolate the microgrid from large networks would provide highly reliable electric power. Highly reliable electric power. Somebody is driving. With that, they are not muted. Microgrid supplies both electricity and heat to the customers by means of combined heat and power plant, micro turbine fuel cells, photovoltaic system, wind turbine. Please mute yourself. Microgrid supplies both electricity and heat to the
যাই হোক বাবা, ওখানে গিয়ে বেশি ভিড়ে ধীরে ধীরে মানে ভিড় ঠিড়ের মধ্যে যাব না, ধীরে সুস্থে আর কষাস থাকতে হবে, হসপিটাল তো।
And in the name of head AEIE GNIT, they are not muted. Head AEIE GNIT, please mute yourself. The microgrid supplies both electricity and heat to the customers by means of combined heat and power plants, micro turbines, fuel cells, photovoltaic system, wind turbine, right? Therefore, till now, they use this photovoltaic system as stage. Beyond all this, there is a combined heat and power that is also nowadays becomes very popular. That also acts as a DG, right? Combined heat, what is the advantage? You know them all, most of the turbines working on the principle of based on the steam energy. So only produced based on steam energy, only it functions very well, particularly in thermal plant. And usually add some heat, naturally the efficiency increases. That's called combined heat and power. Once you combine some other heat exchanges together with that, then the combined heat and plant is further improved, means efficiency further improved. That also acts as one of the good DGs. That is one among the DGs inside a microgrid. Now, challenges in microgrid. Once you form a microgrid, what are all the other essential things to be done? Protection of microgrid. Automation of microgrid is essential. You have to redesign the protective kind of devices, and therefore then only you can work in a perfect way. The automation of the microgrid plays a very important role. And stable operation during network disturbance. Even there is a disturbance, there is an abnormality. If it is in the steady state mode, there is no disturbance. You're moving on to dynamic or transient mode, there is a small disturbance and further large disturbance. In such a kind of a mode, you want to work with the stable operations. Therefore, it is essential to do such a kind of the microgrid also to be worked in such a kind of a mode. It is normal or the abnormal mode. Therefore, that way the microgrid initially to be tested. Already it is successfully tested. That's why it implemented. Therefore, stable operation during network disturbance. Control strategies for inverters to provide stable frequency and voltage increase of varying loads. Now, control also plays a very important role. Therefore, how to manage the frequency and maintaining the voltage. The morning session there, he explained very well about the managing the frequency and voltage. Okay, that is an important control strategy. What are the advantages? Improve the local reliability. Therefore, reliability, you are maintaining the reliability index as 1. It's the best one. When abroad the blackout it happens, therefore from that they understand the reliability index is not maintained appropriately. Therefore, they have to maintain the reliability index appropriately. The blackout can be avoided. Therefore, from that we understand the reliability, because even in our country, most of the power system has become aging. Therefore, we are now in a position to maintain such a kind of a system. The preventive maintenance compared to all other kind of maintenance, it works perfectly. Once you do it, the reliability naturally improves. Therefore, advantages, once you use this kind of a DGs, it improves the local reliability. Reduce emission. I already talked a lot about emission. Lower the cost of energy supply. It also lower the cost of the energy supply. And improve the power excellence by supporting voltage and reducing voltage dips. And the cost is going on reducing, that we already told you. Now the latest development comes. That's why the cost is reducing. And not only that, it improves the power excellence by supporting voltage and reducing voltage dips. Therefore, the voltage also perfectly maintained with a number of supportive measures, and reduce the transmission loss. I already told you, once the DG comes, the transmission loss is reduced. Improve the service quality. And beyond all this, nothing compared to power qualities, the service quality is also improved. Supplying AC and DC loads using DGs, right? Therefore, supplying AC and DC loads using DG. Therefore, now what is the DG now I'm using? I'm going to show you it metered the AC as well as DC load. To reduce the multiple reverse conversion in an individual AC or DC grid. Otherwise, you can make any reverse conversions. From that, you can meter the AC. That is the way now we are going to form. And the mode is you can select grid tied mode, otherwise isolated mode. Converters are controlled coordinated. What is the way the converters are controlled coordinatedly? To get maximum power from renewable power source. That's the way the controller to be worked. You already heard a lot from the previous sessions how the control on the solar panels to be made and make them to extract the maximum power. That's one kind of an example. I'm also going to touch about it to get maximum power from the renewable power sources. That I make it as a control kind of a concept with my hybrid AC and DC grid to maintain the stable operation of the AC and DC grid. Not only that, you have to maintain the stable operations of this AC-DC grid. That is important. To provide the stable DC bus voltage, that is also essential. And for example, you are meeting out by the solar, therefore you can manage the DC loads very easily. That side by the wind, you can manage the AC load very easily. But the solar and wind is not at all predictable. It may not be included in the power demand. Power demand is a predictable one. Even the predictable one, the solar and wind is not in. Why? Solar is based on the solar potential. Wind is based on the wind dynamics. We can't predict. Therefore, nowadays, forecasting load is entirely different. Now there is a different kind of forecasting comes nowadays. Forecasting of wind dynamics. That is an important kind of a forecast. Even such a way you have to forecast the solar radiations. That is also can be forecast. But there is a number of avenues for your research. Therefore, that way you can select different kind of avenues. To provide a stable DC bus voltage also plays a very important role. Now my hybrid AC DC microgrid. Now I'm showing what is the presentation wise I have shown. That is this hybrid AC DC micro. Please watch on carefully. I've shown one side as an AC microgrid. Other side is a DC microgrid. In between that's AC DC power flow coordinator as shown. Right, okay. There are three different kind of a rectangular box. One is AC microgrid, other one is AC-DC power flow coordinator. This side is a DC microgrid. Now watch on the first one. Here, one of the DG introduced a diesel generators. Here, other one is a wind. From that, the wind doubly-fed induction generator, as well as to get perfect power AC-DC AC converter that is to be utilized here, right? Okay, and as well as winds. For that, we use a squirrel cage induction generator. With that, the wind turbine, we can use such a kind of. From that, we produce a power that is supplied to this AC bus, otherwise AC grid. Next, tidal pace power. The tidal pace power, current and speeds fixed and given over here. Here also, you similarly like a wind. Here also we use a squirrel cage induction generator. Here also we use a squirrel cage induction generator. Now we are using an isolated mode. It's not necessary to close this breaker. If you want to use it to connect it to the main grid, you get excess power. At that time, connect this breaker, then supply to the power to the main grid. That's called utility grid. Main grid is called utility. Through that, it's supplied. Then meeting out all what are all produced for that same place. The AC load is also there. Therefore, this power is metered by this AC load. This side is called as AC grid. Now, coming to the DC grid. Watch on the DC grid carefully. The DC grid buys DC bore AC. That is permanent magnet synchronous generator. Therefore, that is a wind. Here also is again wind. But here the thing is AC to DC. Because the DC bus is supply only DC. Such a way we use it. Similarly, solar radiation temperature, always you know them, solar panels, it always produce DC. To make it a balanced one, use a DC-DC booster converters, then supply to the DC power. Then fuel cell stack, that's fuel cell also produce DC. Therefore now you know them, based on the wind dynamics, wind generators works. Based on the solar radiation, so solar panels works. But in the fuel cell, very important thing. What is the difference between an energy storage device and the fuel cell? Nowadays, energy storage device becomes very popular. In those days, there is a fight between the scientists again. Which kind of energy is to be selected? It's very, very fundamental. Finally, they decided electrical energy as the base remaining energy to be converted. What is the reason behind it? Therefore, we have electrical energy only easily transportable, always easily transmittable. Remaining energy may not be. That's why they finally selected electrical energy. Remaining energy is converted from that, right? Therefore, similarly, once there are a number of fights between this. I already told 2 fights about the grid, about the basic fundamental energy. Even there is a fight between what kind of hertz to be selected as the frequency. Finally, in India, we selected 50 hertz. US, they selected 60 hertz. For each and every selection, there is a history behind it. In IEEE, there is a separate thing we are maintaining. That's called history. Therefore, you got the chance of visiting IEEE.org. Go and visit and know the history. Therefore, that's very interesting. History gives plenty of things to you. How each and everything is formed. How things are successful compared to the other kind of developments. Therefore, that is the way the history shows plenty of things to you. Similarly, now here we are selecting the fuel cell stack. Once you compare the energy storage, why I told you means at that time the disadvantage of electrical energy is it's not possible to store it. Now it is not so. The storage has also improved like anything. Now there is a magnetic storages, and previously only batteries, such a kind of a thing. Now the magnetic storages and plenty of lithium-ion based storage, plenty of different kind of a storage comes. Now, beyond all this, the latest development as well, one is a supercapacitors. That's a big, even maybe come to the level of a large amount of storage. That's supercapacitors. Therefore, why I'm telling all this means that's why nowadays most of the people they start to use the storage. In my hybrid AC/DC grid also I use the storage. Therefore, but you can immediately ask, what is the difference between storage and fuel cell? Once it is charging is continuously available, then we can use the storage. If finally it all discharged, then you have to charge again. But fuel cell is not so. Till the material is available, it works. The material may not existed, then fuel cell may not work. That's the difference between fuel cell and batteries. And what is the difference between this kind of thing, battery and flywheel? Flywheel charges very fastly. That's the thing. Flywheel charges very fastly. Flywheel can be used as AC to DC or DC to AC. Both the ways you can use the flywheel, because flywheels contains motor or generators together with the flywheel rotors. That way, which works very effectively. I've shown the flywheels also. Here it supplies a DC to the DC bus. And next one is the battery. That I already explained a lot. That is a different kind of energy storage. That is lithium-ion based, and as well as magnetic energy storages, red oxide batteries, different kind of the things now it comes. And latest one is the supercapacitors. And now here I use battery storage devices as a bidirectional, using a bidirectional. Here in my AC-DC grid, the battery plays a very important role. Why? That side, the wind energy, such a kind of things may not be dependable because it's not predictable. Therefore, once it may not work, the battery all into hand. We can use at that time the batteries. Therefore, we make it as a bidirectional converters and use this battery whatever way you require, AC or DC. You can use such a ways. And find another one is electric vehicle. This is also going to dominate in future. Another important technology, electric vehicle. Electric vehicle supplied to the grid. It's called vehicle to grid. Otherwise, you can from the grid you can take a power to charge your electric vehicle. That is called grid to vehicle. You supply the grid. It's called grid to vehicle. Vehicle to grid. You are getting a charging from the main grid. That's called grid to vehicle. Both the way electric vehicle works. Very important thing. It moves and supply. No device moves and supply. Electric vehicle moves and supply. That's very important. It comes nearer to your place and supplies. It also even sometimes acts as a hybrid. One is for based on charge devices works. Charging stations are there. It will charge and go continuously. With another one, with another fuel also together, you can use it. And that's called a hybrid. That way also you can use the electric vehicle. Therefore, now the electric vehicles become very popular nowadays. Most of the places, particularly in Delhi, already they started to use electric bus because there's a big pollution. In the cities like Delhi, there's a big pollution. Okay, to avoid such a kind of thing, already they use a bio kind of energies initially. Now they are moving on to electric vehicle, buses, car, everything to work on electrical principles. The pollution is completely reduced. That's why they are concentrating on electric vehicle. And beyond all this, it supplies the power. It discharges wherever you require power. Initially charges. Wherever you require power, it discharges. It supplies the power. So from that, what you understand, some of the places it is in the peak load. At that time, you go and supply the power. What happened? Peak become off peak. That's all. Using electric vehicle itself. Even a small kilowatt make the peak as off peak. That's all. But that is the way it works. That's why one among the very important DGs, big electric vehicles, that plays a very important role in future. It dominates the world because the power plays a very important role. Even make the power of the people, power of the country, the power of those who are managing the whole country based on number of ways, power. Therefore, that's why from that we understand power is essential. Therefore, we have to concentrate on the power, but meet out the power in a smart way. Now the DC load. But now I have given a different kind of a DC resources. You can meet out this DC load from the DC bus microgrid side. Now I explain the AC microgrid separately, DC microgrid. Now in between that, there is a transformer here. I've shown the transformer. An AC-DC power coordinator. That's called bidirectional AC-DC main converter. What do you mean by this bidirectional converter? Once the DC is excess power, it's supplied to the AC. This acts as an inverter. Once the AC is excess power, it's supplied to the DC. It acts as a converter. That's called bidirectional. It's once acted as an inverter, other side acts as a converter. That's why it's called bidirectional AC-DC main. And not only that, there's another backup converter also we provide. Any problem happen to this, we'll manage with this. That is the way perfectly we work, forming the hybrid AC-DC architecture. It works effectually, right? Okay. Moving on to the next slide. Now I'm showing by the configuration-wise the hybrid AC-DC microgrid. Now the configuration-wise I have used only one power stations. Here is the solar radiation, solar panel side, PV, photovoltaic cell as the one side, the DC side. The AC side, wind turbine, wind speed, doubly fed induction generator with the converter, AC-DC, DC-AC converters. Therefore, now use it. Here the boost converter. And the DC load is located here, AC load is here. And if it is excess power, supplied to the utility grid, that's main grid, using this breaker, right? Now the boost converter balances things and supply to the DC load. It naturally, based on the wind energy, the AC side is metered, AC load is metered, and based on the solar energy, based on this boost converter, DC side is metered. But suppose solar radiation is not available, what to do? This battery supply to the DC load. Similarly, the wind is not available. At that time, what happened? Through this main converter, bidirectional converter, converted into AC. It acts as inverter, converted into AC, then supply to the AC load. That's the way it works. From that, we understand this is solar, boost converter, battery converter, and main converter, and transformer, AC load, utility grid with the breaker, wind energy station. Similarly, here this is boost converters, and we're meeting with the DC load through this. This is the configuration hybrid AC-DC microgrid. It's the only simple grid. Finally, we formed it and work out it, and whether it works effectively, tested. It is to be tested. Okay. Now the configuration of the hybrid AC-DC microgrid. I already explained most of the things. DC power sources such as photovoltaic panels or fuels are connected to the DC grid through DC-DC converters. For DC loads such as electric vehicle, speed control motors are connected to DC grid, right? Okay. For DC power sources such as photovoltaic panel or fuel cells are connected to the DC grid through DC-DC converter. For this photovoltaic cell and fuel cell produce directly. There is a different kind of a fuel cells are there based on the chemicals. What kind of a chemicals you prefer it based on that the fuel cell differs. It means sometimes sulfur based, sometimes molten iron based. Number of ways the fuel cells are formed. Therefore, you can choose whatever way you require. And similarly, the photovoltaic panel. Even the panel also differs. I think that most of them talked about plenty on that. Based on the material wise, that is also based on semiconducting material wise. This photovoltaic panels also differs. It works very effectively. And even to get a balanced power, again, use a DC-DC converters here. These are all use of DC power directly. And not only that, to meter the DC load, you can use electric vehicle. Therefore, this peak control motors are connected to the DC grid. The electric vehicles, I already told you, plays a very important role in future because it makes your peak load as off peak very easily. Based on the moment, somebody supplies a small amount of a kilowatt, it makes your peak load as off peak load. That is done in a very clever way by the electric vehicles. The speed control motors are connected to DC grid. But anyway, once you connect it to the main grid, if there is an excess power, the integration with the main grid also plays a very important role. What do you mean by integration? Then integration wise, the voltage to be maintained, frequency to be maintained, all things to be maintained in an appropriate way. That's called integration. The DC energy storage system, that is energy storage. I already told you, super capacitors are connected to the DC-DC bidirectional converters. Therefore, now the storage device, super capacitor also you can connect to the bidirectional converters. Therefore, if it is energy storage, through this EV, even you can supply it to the AC side. AC source such as wind turbine generator, diesel generators are connected to the AC grid. Therefore, AC sources such as the wind turbine generator, diesel generators are connected to the AC grid. Right, okay. Therefore, the AC loads are tied to the AC grid. AC loads are tied to the AC grid. Okay. Then the AC energy storage, such as a flywheel, are connected to the AC grid through AC DC converter and transformer. Now we are moving on to the like flywheels, and even that act as to produce AC. Then to manage the things, even you can change the voltage, such a kind of a concept, right? Not only the converter, you can use a transformer also together. That way you can, what is your, based on your requirement, you can easily manage. And finally, the AC grid or DC grid is connected together by means of bidirectional main converter, right? Okay, AC grid or DC grid is connected together by means of bidirectional main converters. Therefore, once there is a problem in DC side, it is managed based on with the AC side. There's a problem in DC side, it managed based on the. There's a problem in AC side, managed based on the DC side. That's why it's called AC-DC grid. Not only that, to manage this too, there is a bidirectional converters that helps a lot. It is that accordingly it acts as inverter and converters, and it works effectively. Now moving on to the implementation. What is the diagram I already shown? There's an implementation. The PV modules are controlled to extract maximum power using maximum power point tracking algorithm. Therefore, PV, I think so you have a plenty of, through the schedule, I understand, there's a plenty of photovoltaic session. I think so based on that, I'll touch only again one fundamental thing here. Because till now I explained the architecture and operation. Now I'm moving on to the implementation, the control plays a role. I'm making the control on this only through the Mppt. Because I have shown my configuration solar panel. Therefore, through that solar panel is controlled through the Mppt, maximum power extraction, that control. And that way we make a control on the whole hybrid AC-DC system, make it work on effectively. For that, there is only I selected the familiar algorithm. I'm not using any intelligent kind of a concept, nothing. Only I selected the familiar kind of an algorithm. That is, PV modules are controlled to extract maximum power using a maximum power point tracking algorithm, Mppt. There is, you already familiarized, that's the incremental conductance algorithm. Next, perturb and absorb algorithm. Third one is fuzzy logic based control. Fourth one is parasitic capacitors. These are different kind of Mppt algorithms you can use based on your requirement and based on what kind of a way it is to be used. That way you can select one among the algorithms. Converters are coordinately controlled for smooth power exchange between AC and DC grid. Therefore, the converters are coordinately controlled for smooth power exchange between AC and DC grid. Now, if output power from DC source greater than DC load, I already told you, compared to DC load and the DC. So if it is DC source greater than DC load, what to do? Main converter act as an inverter. If the output power is DC source less than DC load, what happened? Main converter, they inject the power, otherwise AC to DC, otherwise it acts as an inverter. That's all. Main converter acts as inverter here. This injector power that acts as a converter here, AC to DC grid. Okay, when DC source is less than DC load. If it is DC source is greater than DC load, then it acts as inverter. That way, the bidirectional converters are very helpful for us in the operation point of view. Therefore, now based on this operation as well as introducing the algorithm, first I'll introduce the algorithm of incremental conductance algorithm. Through that one day I make a control on my AC-DC grid, hybrid AC-DC grid. Now I introduce this way how it is to be helpful for me to utilize this control on the hybrid AC-DC grid. This is incremental conductance algorithm, the peculiar name. How the name to be explained to you to make you to understand clearly. The incremental conductance algorithm is used to determine the various directions of the terminal voltage of the PV module by measuring and comparing the incremental conductance and instantaneous conductance of the PV module. You have to remember the two names. One is incremental conductance, the other one is instantaneous conductance of the PV module. Therefore, this too plays a very important role to select the radiation levels on the panels. The algorithm determine the various directions in terminal voltage by measuring or comparing the incremental conductance and instantaneous conductance. Only based on this two only it is decided where the maximum power is extracted and what condition. The incremental conductance GD is equal to the instantaneous conductance GS. At that time only you can extract the maximum power. I have shown the VI characteristics, V on the x-axis, I on the y-axis, VI characteristics. The VI characteristics at this point, the incremental conductance is equal to instantaneous conductance. Therefore, at that time, you can extract the maximum power. Therefore, if it is incremental conductance greater than GS, this portion is to be selected. This portion is to be selected. If it is incremental conductance less than the instantaneous conductance, you have to select this portion. It is non-linear in nature. This portion is linear in nature. But this too plays a very important role, selecting the values of the incremental conductance based on the VI characteristics wise. Now, incremental conductance algorithm continues. When the operating point of the PV model is in constant current region, then the slope of the power curve is positive. Now we select the slope you select the PVI characteristics. It involves V and I. Okay, now instead of that, I'll select a power and voltage here. Both are almost the same. PV model is a constant current region. Then the slope of the power curve is positive. What is that? dP by dV greater than 0. From that we understand dP by dV. That rate of change of that dP by dV is greater than 0. Or that is called increment. When the operating point of the PV model is beyond the maximum power point, then the slope of the power curve is negative. Then if previously the slope of the curve is positive, that's why dP less than dP by dV greater than 0. Now dP by dV is less than 0. If it is negative, it is less than 0. The incremental change is less than 0. The incremental change is greater than 0. But when it is equal, when the operating point of the PV model is exactly in the MPP, then the slope of the curve is equal to 0. That is dP by dV equal to 0. You know that. When we get this maximum, according to mathematics, you know the maxima wise, we differentiate this voltage with respect to power. We differentiate the power with respect to voltage. That is equated to 0, that is maximum. That's why dP equal to dV equal to 0. At that time only you can attain the maximum. That's the same kind of a concept we find out dP by dV equal to 0. We are going to find out that attainment of the maximum. This is similarly like a mathematical concept. Again here to attain the maximum value. What is the way? This can be expressed as dP by dV. But that is dP by dV, it is equal to dVi by dV. Differentiate the Vi with respect to V. What happened? First you get I plus V into di by dV. Di by dV. I plus Vi into di by dV. That's what you get. You differentiate this Vi with respect to V, right? As dP by dV equal to 0. You know then dP by dV is maximum wise 0. So make it this as 0. What happens? dP by dV is 0. But this 0 is equal to this equation. Then what you get? Your dV by di by dV comes over this side. That is equal to minus I by V. Minus I by V. The same equation. After putting the value of dP by dV is 0, you get the value as di by dV equal to minus I by V. Here, watch carefully. I by V, that is conductance. I by V is conductance. When it becomes incremental conductance, because of di by dV, that's why it's called incremental conductance. That is GD. di by dV is GD. That is incremental conductance. Instantaneous. I use only a small letter, but you have to use a small letter. I'm using a capital letter. It's not right. You have to use a small letter. Then only it's instantaneous. Minus small I by small v. Okay, that is called as an instantaneous conductance. This is also I by V. That's why it's called conductance. But it's the instantaneous value. Small minus small I by V. That's why GD equal to GS. Now it is proved. GD equal to GS. At that time only you can extract the maximum power. Maximum power. Otherwise not possible. At the time of instantaneous conductance is equal to the incremental conductance. At that time only you can extract the maximum power. That is the importance of incremental conductance algorithm. If the operating point is on the left side, less greater than minus I by V, you can understand the left side of the curve, this side. Okay, the right side of the curve, this side. You always imagine this curve, then only you understand this. If the operating point is on the left side of the curve, then di by dv equal to minus I by V. Okay, otherwise gt is greater than gs. That side I already shown. Gt is gs. Okay. Similarly, dp at that by dv is greater than 0. The operating point is on the right side of the curve. Di by dv is minus, whether gd is less than gi. Less than gi. Okay. If it is less than gi, the nature is nonlinear. Here the nature is in linear. Always mind it. Now at that time, dv by dv equal less than minus I by v. Therefore, gd is less than gs. Then dp by dv is less than 0. Right? Okay. It is less than 0. If the operating point is on the right side of the curve, it looks like this. Now I explain the right, when to be the right side selector, when to be the left side. When it is the maximum, when it is only gd is equal to gs, at that time the maximum power is extracted. Okay, that is called as the incremental conductance algorithm. Now justify the wording or naming of the incremental conductance algorithm wise. Now continuation of that, what is the way we fix the controlling? Again, I will draw a curve based on the scaling of y-axis wise power, x-axis wise voltage, right? It's shown in a different way. But the maximum power point is based on the illumination effect, W by meter square. Illumination effects. For that value, G value is first 400. You get the curve is like this. The radiation level of the curve is like this. G is 60, you get this level. What do you mean by that? Respective to the voltage, the power is more. Similarly, 800 again increases power increase respective to the voltage. Again 1000, it further increases. Therefore, for that, in this we select one point that maybe select as A. Based on the TA, we work further. That's the way it works for. Therefore, the power versus voltage curve of a PV model at different radiation level. Where the illumination effect is based on a different radiation level. Therefore, based on the radiation level you selected, accordingly you get the appropriate power. Therefore, that is the way it works. Then, first base you have to select, making control, you have to select appropriate illumination level. Next one, based on the control wise, what kind of voltage to be selected. Based on that, you can fix the power. That's the way the control to be selected. Now, flowchart for incremental conductance algorithm. We'll start. Once we make measurements, VFN is the initial value, voltage. IFN is the initial. The next value, we move on Vn minus 1, In minus 1. This is all measurable quantities. This is to be given as an input. You have two values. From that, you can find out a di. In minus 1. You can get a di. Vn minus Vn minus. Vn minus Vn minus. You get the dv. Get di and dv. For example, dv is equal to 0. If it is no, it is to be connected to B. If it is yes, it is to be connected to B. If it is connected to A, no, what happened? di by dv is equal to minus I by V. di by dv equal to minus maximum Mppt, maximum power records. If it is yes, this condition is equal to yes means this comes over here. Otherwise, no directly. di by dv is greater than minus I by V. It checks again. If it is yes, what happened? Based on the previous voltage, small incremental voltage added. But if it is dv is greater than minus I by V is no, this is not satisfied. Then what happened? Based on the previous voltage, dv, what is small incremental voltage is subtracted. Here it is added, it's subtracted. That is the way finally supply the voltage. But if it is the BC side, what happened? dei equal to 0. B side, if it is no, based on the previous line. If it is no, dv is not equal to 0. If it is yes, no only where this side. Yes, if it is yes, dv equal to 0. What happens? Only the current. If the current is 0, dv is 0, current is 0. Then what happens? Current is 0. If it is yes, That's it. No means di is greater than 0. Then what happens? It adds this. J is greater than 0? No. It's subtracted. If it is yes, add. That's the way it comes. The final value comes over here. Update the Vn minus 1, In minus 1. What is Vn minus 1? As Vn to be Vn minus 1. I of n is In minus 1. That's the way it goes on updating. Then it returns back. That is the way the inductance, incremental inductance algorithm works effectively. Now the implementation of MPPT with boost converters. How this implementation of MPPT with boost converters, right? Okay. But there is a solar panel. The solar panel wise is connected to the MPPT controller. I already told you in my part, I use MPPT as a controller. For that, through the solar panel, voltage sensors gives the voltage to the MPPT. Similarly, the current sensors give the value as an input to the MPPT controller. Based on these two values, MPPT controllers works effectively. Then it's extract the maximum power and supply over here. That is based on the converter value, DC-DC power. Finally, it converts and supply to the load. That is the way it works. Implementation of MPPT with boost converters. That boost converters and MPPT already are shown on the main diagram. With that, now I added the controller, that's all. Previously explained architecture, operation, now added the controller, that's all. That is the way it works. I will not use anything as the latest one. Only the conventional kind of things I used it. You can use the latest kind of thing, make as a new paper or as a new research. That is possible at this stage. The operation of the hybrid microgrid. Operation of the hybrid microgrid. Hybrid grid can operate in two modes. I already told you. Grid-tied mode is the islanded mode. The grid-tied mode is a very different kind of a concept. Therefore, it is to be integrated with the main grid. With that only, then only the grid-tied mode works effectively. The islanded mode also, the islanded way, everything to be work appropriately. In both the way kind of a mode, the difficulties is to be overcome. Therefore, you have to manage, otherwise maintain frequency in a perfect way. In grid-tied mode, the AC grid is connected to the utility grid. Therefore, the grid-tied mode, AC grid is connected to the utility grid. Utility grid means nothing but connecting with the main grid. During the fault in the utility grid, microgrid operate in the islanded mode. Therefore, there is a fault, it happens on the main grid. You can isolate and work separately. That's called, at that time you can prefer the islanded mode, because the main grid always happens. It works on sometime normally, sometime abnormality happen. Abnormality when it happened due to fault, sometime due to over voltage. So a number of ways it happens. That time only the transient it occurs. That's abnormality. That too with a very large disturbance. And with a small disturbance, dynamic kind of a thing also works. But once you come to the level of a dynamic and transient, it perfectly works based on the function of time. And effectively, we can produce a plenty of result through that. Right, okay. Even the abnormality happens on the system, which works very effectively. Main converter is controlled to control the smooth power exchange between AC and DC grid. Therefore, the main converter is controlled to smooth power exchange between AC and DC grid. But there is a smooth power exchange between AC and DC grid. What is the way based on the main converter? The main converter acts as a bidirectional converter. Because of that, the smooth exchange it happens. Otherwise, it may not be. The PQ control or tube control can be used to control the main converter. Therefore, till now I used an ordinary kind of control. Now you can use a tube controller. In the morning session, the tube controller explained very well. Therefore, you can use such a kind of a tube controller here. Can be used to control the main converters. Right. Therefore, such a way here in our work also we use a tube controller. That too only a convention, not a latest kind of a tube controller. The morning session, we introduce the latest kind of a tube controller also to you. A real and reactive power. The controllers plays a very important role nowadays. Through that only you can make control on the whole thing. What is the way you supply to the power? Otherwise, managing the AC-DC grid also in a perfect way using this kind of a controllers. Real and reactive power exchange is combined with help of PI controller. Therefore, real and reactive power exchange, because once you use a tube controller, based on the P axis and Q axis, real and reactive power exchange that happens. And that too with the conventional kind of a PI controllers, right? Therefore, it works effectively when the real is directly proportional to current reactive is directly proportional to voltage. If it goes on the based on a perfect kind of an equation, sometimes real is proportional to the voltage angle, and the reactive is based on the voltage, right? Okay, that is the way it perfectly works. Therefore, here the real and reactive power exchange is controlled with the help of PI controller. Therefore, during the islanded mode, energy storage system operate as energy buffers, right, for balancing power surplus and shortage and maintain the system stability under various load conditions, right? Therefore, now here, once if it works on the islanded mode, what happens? Energy storage operates as an energy buffers. If it is islanded mode, you can't get any more power from the main grid. But any problem happen, you have to manage. At that time, energy storage plays a very important role, which act as an energy buffers to balancing the power surplus or shortage. Therefore, if it is a surplus or shortage, both the way it managed very well. That's why it's called as the energy buffers. And maintain the system stability. Not only that, even maintain the system stability under various load conditions. Therefore, low condition may always, it may be an islanded one, or it's connected to the main grid. Always you get a various kind of a load. Variation may be there in the load. Okay, that's very important. Even integrating this kind of a green energy, otherwise renewable energy with the main grid, otherwise even separately works in islanded mode. What's the problem? Renewable energy is highly invariable. That's why the integration phase very, the conventional kind of a thing is not so. You get a constant amount of power. But in the renewable kind of a things are highly invariable. It goes on varying. So with that, maintaining a number of things, voltage, other kind of things, it's very, very difficult task in front of you. That's why the integration plays a very important role, not only in the islanded mode, not only in the grid connected mode, the islanded mode also. So you have to maintain everything in a perfect way. Then only the system also maintain in a stable way. Otherwise, it may not be stable. Therefore, we have to maintain a system in the normal. For example, you are designing a new kind of a thing. It is to be tested in the steady state as well as the transient state. For example, you design a line, go and erect it. You have to erect such a kind of a line. What do? You go and erect such a kind of a line in the open space. It has to meet out the normal and abnormal condition, because the line is kept at the open space. Any lightning thunder happen, at that time also the line to be withstand. Lightning thunder is a very important thing in electrical. It's produces a very high voltage and it discharges from the cloud, and it is even affect the traveling wave phenomena of the transmission line. Therefore, that plays a very important role. The transmission wise nowadays, the voltage is going on increasing. We can boldly say we are one of the developing countries, the transmission voltage range wise. What is the way? One is the high voltage side. Till now, 400 voltage high voltage, 765 till then high voltage. So it goes beyond 765 extra high voltage. 400 to 765, it is extra high voltage. It goes beyond 765 to 1200, it is ultra high voltage. Such a way it goes on. Therefore, already in India, voltage, the transmission voltage level wise, they already erected 1200 kV. Okay, therefore in the North India already they erected such a kind of a line. That's why extra high voltage transmission wise, we are one of the developed country. Not only that, even the DC wise, now we already erected the 800 kV transmission line, DC sideways, between Agra and started from the Agra. That is the way they already erected DC transmission line. Therefore, even the DC transmission line wise, AC transmission line, we are one of the developed country because we attained the maximum level. Therefore, we are realized mega, we are realized giga, mega from kilo, mega, giga. The electronic side, from milli, micro, we are moving on to the nanotechnology. Similarly, electrical side, kilo, mega, giga. Giga, example for giga is this kind of a voltage range. We already attained such a kind of we move on to the very high voltages to reduce the loss. I think that's the main motive. And instead of that, you prefer a DC, this kind of big voltage range is not at all required. You don't not require a big kind of a transformers like power transformers. The transformer used inside the medium type of substations in the transmission lines is called as the power transformers. Similarly, you put the individual generator produce a large amount of power. That's a big size generator. That's called, name of the generator is called as the turbo generators. Therefore, such a way we can use different kind of things. Now, that is in future technology, these are all may be eliminated. Once the DG comes into the level of nearer to the load level, then there is no question of big generator, there is no question of power transformer. These are all not at all required. Okay. Therefore, the future direction goes based on the power system restructuring. Second was based on the smart grid natures. This two all become successful. The whole scenario is different because power system is restructuring required the concept of completely introducing a power market. Already the Indian market is existing. The similar kind of way, there is a power market that side. Similarly, there is a smart grid is there. But once you start to use the smartness, it comes and it works. This re-engineering is required. You successfully make it restructuring and re-engineering. Then you successfully implement the power system restructuring and smart grid. I got the chance of visiting US at Baltimore. The Baltimore, I have seen the power exchange practically. Each and every time the power exchange, power bit value or power bit cost goes on changing. That one I exactly see because they already implemented. That's why the power exchanges are working very effectively in abroad. Similarly, like a market exchanges, the power exchange also works effectively. But in India, the power exchanges are only in the testing stage. Now they all are going to implement. In a few years, we know them. Whether this is successful or not. But that way, the direction goes. Now, I explain the last part of my slide. That is coming to the last part of it. Is during islanded mode, energy storage system operates as energy buffers for balancing power surplus or shortage and maintain the system stability under various load conditions. Now, continuation that main converter uses main grid electrical signals as references, right? The electrical signals as a reference, that way the main grids works. We always require references, then only the converters works effectively. To control the active power through DC buses, VDC is compared with its references. Again, to the DC bus side, the VDC references are compared, and that way the control works effectively. Next, DC bus voltage error feeds PA controller having a current reference as the output, right? Okay. Here also the current reference is selected and compared with the main currents. That way the DC bus voltage is without error, it works perfectly. And it is to be all this to be worked perfectly, or to introduce a new controller that's called troop controller. That is Q-axis make current control on the current Q-axis set by Q-axis voltage. Make control on the voltage, Q-axis control is to control the reactive power flow. This side is reactive power flow, other side, Q side is real power flow. That is the way it's worked perfectly. Make a control on that. You introduce not only Mppt kind of a controller. I also introduced a troop controller based on the Q-axis and Q-axis current and Q-axis voltage controller wise. It works effectively, the troop controller, and gives an appropriate control on the voltage as well as on the current. D-axis current is set by DC bus voltage. This is to be used at the DC side. D-axis current is set by DC bus voltage controller. Control the active power flow between AC bus and DC bus. This control, perfect control on the active power by the D-axis control in the DC bus side. Therefore, once you use a troop controller this way, this maybe works effectively, and make a control, and based on your requirement, it satisfies your requirement and works on perfectly. And finally, I'll come to my end of the part of my presentation, that is using the conclusion slide. The architecture, operation, and control of the hybrid AC micro has been discussed till now. I have given the clear architecture, the ordinary kind of a block diagram architecture, as well as and the circuit kind of architecture I have presented, and how it is operated I explained, and what is the way it is to be controlled, that is also explained. The AC-DC microgrid has been discussed. And the hybrid grid may be feasible for small islanded industrial plants, educational institutions, or a commercial building with the help of distributed generation as a major power supply with the following advantage. Now, The hybrid grid may be feasible. Always mind it. The word feasible plays a very important role in power system. It satisfies all kind of a constraint that's called feasible. If it satisfies some of the constraints, it's not feasible. It is not feasible. Satisfy all, it is feasible. Okay. Similarly, you controller, you use the word robust. The robust kind of a controller works in normal as well as abnormal condition. Both the way it works. Then only it's robust. Otherwise, it may not be robust. The education institutions or commercial building help distributed generation as major power supply with the following. And therefore, no doubt about it, educational or commercial or otherwise industrial plant. They have to buy metered by power by themselves in future. For that, the hybrid kind of a grid plays a very important role. It naturally contains plenty of DGs, distributed generation. That supplies a major power supply. That is, once you use it, what is the advantage? Improve local reliability. I already told you, once you want this kind of a microgrid, ACDC, it improves the reliability. Even you can calculate the reliability based on the reliability index. It just maintains a 1 index as a maximum. It's a very good one. It's very possible, not possible to attain all 1. Nearer to 1. You can attain nearer to 1. Improve the local reliability. Therefore, nowadays, most of the power systems are aging. It is essential to concentrate on the reliability to improve the reliability index further, making the grid as hybrid AC. Already hybrid AC, the grid is available. Introduce a AC/DC microgrid. That way you can improve the reliability. Reduce emission. Therefore, once you use it, the emission, carbon emission also reduced a lot. Eliminate the thermal energy. Instead of that, introduce this kind of a DGs. Through that, you can reduce a lot of emissions and you can save a lot of emissions. Through that, you can save the pollution. Otherwise, you can maintain the pollution. You can avoid the pollution. You can avoid the pollution. The low cost of energy supply. The third one is low cost of energy supply. Therefore, low cost of energy supply. Therefore, naturally, most of them think that it's costly. It is not so. Even you can meet it with a low cost. Therefore, that's why now renewable. Those days, the photovoltaic PV photovoltaic panels are very costly. Nowadays, it is not so. Similarly, most of the costs are reducing. That's why it becomes low cost. Therefore, you have low cost energy supplies. Once you use the DGs, it acts as a low cost. Even the conventional kind of micro turbines, that is based on the gas turbine, that also produce power with the low cost. And reduce transmission losses. Beyond all this, once you locate the generating station nearer to the load stations, therefore you are reducing, it always reduces the transmission losses. There is no question of talking about receiving end, sending end. Now, both ends are nearer. Therefore, there is no, once you use the word end users, both are in the end users, only at the end side, end user side. It is not, therefore, there is no question of talking about different kind of ends. Only one end is maybe available once you implement all this. At that time, you can realize the reduction of the transmission loss. And finally, it improves the service quality. Through that, it improves the service quality because once you maintain the reliability, what do you mean by the reliability? Maintaining the reliability, nothing but maintaining the reserve appropriately. Any problem occurs, meter based on the reserve. That is a good reliability. Through that only you get a good reliability index. You can make such a kind of a planning, planning level or in the operation level. Both the way you can do it. And finally, improve the service quality. You can make the service quality to be done in a better way. Once you move on to this kind of a formation of a hybrid AC/DC microgrid. And finally, power quality. Power quality also essential. The power quality, once you talk about it, you think that introducing a fax device is and only in the transmission side. It is nowadays introducing a fax device distribution network also essential to maintain the quality and based on the harmonics elimination, higher order harmonics to be eliminated. And through that, you have to maintain the power quality in appropriate because you are introducing the power electronics. That's why some of them may not produce a real power. Most of the DGs may not only produce a real power. You have to run the system only with the reactive power. You require a complex power, then only you can run the system. For that, you require power electronics. Once you start to use the power electronics, naturally the power quality problem comes. Or you have to eliminate the power qualities. For that, you have to use a different kind of a compensating devices. Very popular device is a fax device. Therefore, even this decade popular technology, one of the last decades popular technology, one of the last decade popular technology according to the IEEE device, fax devices. Only device from the power engineering is fax device, that much popular fax device. You want to know the fax device reality. You got the chance of visiting Bangalore. I think so. That there is a laboratory, Center Power Research Institute. There is a laboratory there here that you can practically see how they are testing the transmission line, how they are testing the insulator, everything you can see in this. There is a CPRA, Center Power Research Institute, and that there is a real-time simulators also there. There's a big computer station there. They already installed a real power simulator. That is cross and cross. The cost of that is cross. What they are doing it nowadays, when the Avenue of Power System Laboratory opens, because the computers, they bring all that in with a single line diagram inside the computer. Before they are going on checking, analyzing, applying the load flow analysis, all the voltages maintained, what is exactly the last value, everything they are calculating by the way of simulation. Now the popular simulation packages are available like ETAP, CSCAL, plenty of chapters packages are available. My Power, like that. Therefore, using such a kind of package, you can simulate your own system. Maybe, for example, you belong to Andhra, the Andhra system is completely formed through the single line diagram. At that time, anywhere there is due to that, there's a voltage problem, or the compensation is essentially required. What is the way to be tested? Using a real-time simulator, simulate everything, and fix your practical fax device exactly on the transmission line on that together with that diagram. Check the values. That value is fax device. Going on checking. When the violation, nothing can happen. It works perfectly. After applying the low flow and making a monitoring on this. When you get the perfect values, finally select that power fax device and go and erect it exactly on the practical field. That is called as a real-time simulator. It's an amazing kind of a thing. It's a wonderful kind of a thing. You can realize that real and as well as this kind of real-time simulator also available. Number IITs, IISCs, right? Some number of places. You got the chance of visiting and go and visit and realize such a kind of a things. But that why I explained in the last part is improved power quality. The power quality is playing a very important role. Once you introduce the reactive fax devices, it not only compensates the reactive power, it also compensates the real power. Compensating the reactive power not only maintains the voltage, it also reduces the losses. Very important thing. Most of them think that it is losses only depend on the real in nature. It is not so. Okay, even the reactive nature changes because of the losses changes. It further, once you concentrate on improving the reactive side, the losses further reduce. That is also a very important message. I think so. With that, I almost come to the conclusion, my part. I think so. Some more time is there. You have any kind of a question, I'm happy to answer it. The question not only belongs to the power engineering, any kind of a question can be raised. I'm happy to answer it.
Thank you, sir. Sir, one question is posted in the chat box. Shall I read that one, sir?
Yeah.
Yeah. What are the energy storage methods used in hybrid microgrid?
Here we use the four ones I told you. Here we use an ordinary kind of energy storage only, battery. What is the model I have shown? Here we use only the ordinary kind of an energy storage, but you can replace that one as a lithium-ion kind of energy storage, or otherwise one or any kind of a magnetic energy storage, or any kind of red oxide battery-based storages. Otherwise, even with the supercapacitor, you can use it. But always by first time based on simulation wise, then you can use it. You got any laboratory kind of a setup, you can even practically also you can test it. But anyway, most of the time we always check this with the simulation kind of. Any other queries? I'm happy to answer it. Anybody can unmute and raise a question. any kind of those who are doing research, those who are going to do research also can raise a question. Okay, if there is no question, no problem. I'll hand over the things to
Yes,
the organizers.
yes, sir. Thank you, sir. I request HOD sir to give the vote of thanks.
So good afternoon, sir. I'm Sudhir, HOD of Tripoli, SV College of Engineering, sir. So from my end, I would like to answer. I would like to ask one simple one query, sir. Sir, how this converter rating affects in AC/DC microgrid integration, sir?
Converter rating.
Yes, sir. Real-time perspective. So, is there any standards already established, or we can go for changes with the choosing selection of the ratings?
Here we use a boost. So some of the standard converters, we are not using any kind of latest one. And then what is the way the old kind of a converters ranging a fix a similar kind of a way we can fix it here. There is no problem at all. Okay. And not only that, if it is any kind of IEEE standards are there, you can follow that standards also.
Okay, sir. So it means, for example, I'm going to design with a new control algorithm. So I can go for selection of, I'm free to select the ratings of this particular converters, right, sir?
Yeah, free to select it. But if it is you are using only in a simulation kind of a thing, but yes, you are moving on to the utility entirely differs.
Okay, sir. Yes, sir. So thank you, sir. Thanks for answering, sir. So on behalf of participants, I can convey one thing, sir. The session was really helpful for our today's participants because you have explained in a very clear manner about the AC/DC grids as well as the DC/DC microgrids. What kind of challenges are there in AC/DC as well as DC/DC microgrids, and you covered the all the challenges like power quality issues, reliability issues, restructured power system. Also, you pointed very well, sir. So that really helpful. The researchers who are especially focusing on this AC/DC microgrid, sir. It will be honor for us to have you as a resource person for our ACT-STTP phase 1, sir. In future also, we will request your collaboration. Thank you so much, sir, for spending your valuable time with us. Thank you so much, sir.
Thanks a lot. Thanks a lot. I'm always with you. I have another plenty of topic also. It suits based on your suitable to your theme of the work. I'll definitely deliver. No doubt.
Yes, sir. Thank you so much, sir.
Thank you, sir. Thank you.
Yeah. Participants, thank you for your patience. Hope you have gained more knowledge in today's sessions about the microgrids in the morning as well as the afternoon session also. So tomorrow also we'll be having a practical kind of a session from industry, one person from industry and another from a person who is directly in contact with the power plant. So it will be a really useful session. Please just join before 10 minutes so that we can spend more time. Thank you so much. We'll meet tomorrow once again. Thank you.
Thank you, sir. I'm leaving. You send the feedback also to me. Thank you.
Sure, sir. We will share, sir. Thank you so much, sir.
Thank you.
Have a good day. Have a good day, sir.
Thank you.
I request the participants to fill the feedback form which is already posted in the chat box within 5:30 p.m.